Even though AWS provides a lot of managed services for different use cases, EC2 still remains as one of the most used AWS services to host compute instances for various workloads like web servers, application servers, database servers, and much more. Having a base AMI with all the tools, packages, and software pre-installed is crucial for such workloads, enabling us to quickly build our EC2 instances based on these golden AMIs. EC2 Image Builder is one such service which makes building these golden AMIs super easy. And in this video, we'll go through the process of creating, managing, and distributing these golden AMIs using EC2 Image Builder. Hello folks, if you're new to the channel, I'm Prasad Domala and I'm a senior cloud architect and DevOps engineer. And on this channel, I'll be sharing my knowledge and experience on AWS Cloud and DevOps, providing tips and tricks to help you navigate this powerful platform. So let's dive in. First, let me briefly talk about the capabilities of EC2 Image Builder. So EC2 Image Builder is a fully managed service which helps us to automate the process of creation, management, and deployment of server images. As you can imagine, each application or organization will have specific requirements in terms of operating systems, package versions, and so on. And Image Builder allows a lot of customization for such use cases. And AWS provides some predefined components, or we can build our own components. And we can combine these components and build our recipes based on our requirements. And EC2 Image Builder also helps us to keep our environment secure and up to date by periodically building AMIs with latest security patches and updates. Also, there is no additional cost to use Image Builder, but you'll be charged for the resources Image Builder spins up to build your images. I'll talk more about pricing later in this video. Image Builder supports all major operating systems and versions like Amazon Linux, Windows Server, Red Hat, CentOS, Ubuntu, and SUSE. And Image Builder supports AMIs, that is Amazon Machine Images, using which we can launch our EC2 instances. We can also build container images using Image Builder and use them in ECS, EKS, or any other container-based service from AWS or other cloud providers. So in this video, we shall be concentrating on building Amazon Machine Images. As I mentioned earlier, there is no additional cost involved in using EC2 Image Builder, but we'll be charged for the resources EC2 Image Builder creates in the process of building our image. A temporary EC2 instance is launched to install all the software and packages we define. So this instance is temporary and will be terminated after the image is built. So we'll be charged for the time the instance is in running state. This depends on how long does it take to install and configure all the software required. We also get charged for the EBS volume attached to the temporary instance and its corresponding snapshots as well. Next service that we'll be charged against is S3 if we opt to store our logs in S3. And I strongly recommend to store logs during our image building process as it will be really helpful for troubleshooting purposes. We don't need these logs for long anyway, so we can set lifecycle rules on the bucket to save some cost there. If we opt for validating the images using Amazon Inspector, there will be an additional charge for that. In case of container images, we'll have ECR specific costs as well. So that's a brief overview of the costs involved with Image Builder. Now let's briefly talk about how EC2 Image Builder works. And the first piece of config for Image Builder is the base AMI. And it can be any official image from AWS like Amazon Linux, Ubuntu, or Windows. It can also be a third-party AMI from various vendors on AWS Marketplace. Or it can be our own private AMI built within our AWS account. Image Builder takes this base AMI and installs or configures all the software packages. The core config item within Image Builder is called a component. And there are many AWS provided components like CloudWatch Agent, AWS CLI, Code Deploy Agent, Python, .NET, and many more. Apart from these AWS provided components, we can build our own components using something called as action modules. All these components are defined in YAML format. So we'll discuss those and build some custom components using these action modules later in this video. And all these components are bundled together in a resource called as image recipe. So image recipe is nothing but a collection of components. And we can create recipes based on our requirements. Say for example, we can have a web server recipe with Apache and other related packages installed. And similarly, we can have another recipe for a database server with MySQL and related packages installed. Next, we have infrastructure config, and this defines the infrastructure configuration required for our temporary EC2 instance, which is launched by Image Builder during the build process. And this config includes VPC, subnet, security group, instance profile, tags, and so on. Next, we have distribution config, and this defines how we want to distribute our AMI once it's built successfully. And this can be regions, accounts, organization IDs, ASG, launch templates, and so on. And all these resources, that is components, recipe, infrastructure, and distribution configurations, form what is called an image pipeline. Along with these, we also have a schedule for the image pipeline, which is a cron expression using which you can automatically build and distribute images on schedule. And finally, we have an optional IAM role called EC2 Image Builder Distribution Cross-Account role, which, as the name suggests, is required if you want to distribute the image to other AWS accounts. So whenever the pipeline is triggered, Image Builder takes the base image, launches an EC2 instance based on the infrastructure config, installs all the components defined in the image recipe, and finally distributes the AMI based on the distribution config. And for the sake of this demo, I have 3 accounts: shared, dev, and prod, and we'll be creating the image pipeline in the shared AWS account and distribute it to dev and prod AWS accounts. Now let's get into some action by creating an image pipeline. I'll be using CDK with TypeScript for this demo, and I have already initialized the CDK project with an empty stack. If you take a look at my CDK JSON, I have the base AMI as Ubuntu 22.04, which we'll be using as the base for the image pipeline. I also have 3 environments configured: demo dev, demo prod, and demo shared. And I've also added a VPC ID for different environments, and we need the shared VPC ID to create infrastructure config for our image pipeline. And as I mentioned earlier, we'll be creating the image pipeline in the shared account and distribute it to the dev and prod accounts. If you want to know more about multi-environment CDK setup, watch my video on that topic. I'll leave the link in the description. Now let's start building our stack, starting with the image builder role and corresponding instance profile. And this role will be attached to the temporary EC2 instance during the image build stage. So if we need any AWS permissions while building the image, we add those permissions into this role. So let me paste in the code for the EC2 image builder role and fix the imports. Here I'm adding a condition to deploy this role only to a demo shared account, as we'll have the image pipeline in the shared account. So we don't need this role in other accounts. For permissions, we have 2 managed policies. The first one is EC2 instance profile for image builder. This role is required for image pipeline, and it will give KMS, S3, and image builder permissions. And it also gives CloudWatch logs permissions as well to be able to send image builder logs to CloudWatch. I'm also adding SSM managed instance core permission. This is not a required permission, and we need it only if you want to log into the temporary instance using SSM during the build process. Next, let's add a corresponding EC2 instance profile. I'm just setting the name and the role for the instance profile here. Let's quickly deploy this stack to make sure we set it up correctly. I created a simple deploy script where I'm just setting the environment based on which environment I'm deploying the stacks to and executing CDK deploy. So I'm executing deploy.sh script, providing demo-shared as my environment. Our stack is now deployed into the shared account. Now let's look at how we can create our components. And for the sake of this demo, I'll use a couple of AWS managed components. Specifically, we'll use AWS CLI v2 and CloudWatch agent components. If you want to look at all the available components, we can navigate to component section from the EC2 Image Builder console. From the drop down here, select AWS managed components, which will give you a long list of components for different operating systems. Let's search for AWS CLI, and we can see AWS CLI v2 component for Linux and Windows. If we click on the component name for Linux, we can see the content of the component, which is in YAML format. Each component has some metadata like name, description, and schema version, and the schema version should be 1.0 at the time of recording this video. Next, we have 3 phases called build, validate, and test, and at least one of these phases is required to create a component. And build phase is used during the build stage, where you can execute commands on the temporary EC2 instance, which will then be used to create our AMI. This can be anything you want to install or configure on the AMI, like Apache installation, Node.js installation, configuring system settings or file systems, and much more. Validate phase, as the name suggests, can be used to validate our build steps, like checking the version of Apache or Node.js and checking our file system permissions and so on. And both these phases are executed on the temporary instance during the build stage. The test phase is used to test our AMI. So this phase is triggered after building the AMI. A new EC2 instance is launched based on the new AMI and executes a series of tests we define in the test phase. For example, if we need Apache to be started when a new instance is launched based on the AMI, we can add that step to the test phase. And each phase will have a corresponding name, which should be one of build, validate, and test. And as you can expect, each phase can have multiple steps. Each step is nothing but an action that needs to be performed and any input parameters that action expects. And these actions are predefined by AWS, and they call them as action modules, which can be divided into 5 categories: execution, file upload or download, file system operations, software installation, and finally system actions. And within general execution, we have execute bash, which, as the name suggests, can be used to execute any bash commands, and it is supported on Linux. Next, we have execute binary, which can be used to execute exe files on Windows or any binary executables on Linux. Next, we have execute document, which is nothing but another component YAML file, basically nesting your YAML files if required. And execute PowerShell can be used to run PowerShell commands or files. Under upload and download, we have S3 upload and S3 download, which can be used to upload and download files to and from S3 buckets. We can also download files from web using web download action. And file system category contains actions related to most common file system operations, like creating, deleting, or moving files and folders and setting permissions and so on. Software installation contains installation or uninstallation of MSI files on Windows. And finally, under system actions, we have reboot, update OS, and setup registry, which is to set up Windows registry items. And each of these actions have different options. We can't go through all those options in this video, but I'll leave the link to AWS docs if you want to know more about these action modules. Now let's create a couple of custom components, one for Apache and one for Node.js. Let me create a folder called components and add 2 YAML files called apache.yaml and nodejs.yaml. Let us first work on the Apache component. First, I'm adding the metadata. I'm just providing name and description for the component, and the schema version should be 1.0 at the time of recording this video. Next, we need to add phases and steps within those phases. The first phase is the build phase. And within the build phase, I'm adding a step to update apt repositories. Each step will have a name and action from the actions we discussed earlier in this video. We also have optional inputs, and these inputs are specific to the action we are using. For example, for execute bash action, we need to provide commands, which is nothing but a list of bash commands. Next, I'm adding a step to install Apache. As you can imagine, we can use execute bash action to run any bash command depending on our requirements. Next, let's move on to validate phase. And within validate phase, I'm adding a step to verify if Apache is installed, again using execute bash action module. And I'm using dpkg-query command to check if Apache 2 is installed or not. If this is installed, I'm just echoing that the package is installed, and if not, I'm echoing a message and exiting with the exit code 1, which means something has failed, which basically means that the image pipeline status will be failed. Next, let's add a test phase. And within test phase, I'm adding a simple test to check if Apache is enabled and active. Here you can see an additional parameter called loop, which basically gives us an option to loop through values and use them in our commands. In this case, I'm looping is enabled and is active, and I'm using loop.value as an input to my systemctl command. In other words, this step will execute 2 commands, that is systemctl is enabled Apache 2 and systemctl is active Apache 2. If the exit code is not 0, the step will fail and the test phase will fail. So that is a full component defined in YAML. And this one is a simple one, but you can build complex components based on this structure and action modules we discussed earlier. Let's create a similar component for our Node.js. This YAML file looks pretty similar to the Apache component, except I don't have the test phase. Also in this Node.js component, I wanted to show you how we can add parameters to our components. For example, we don't need to create separate components for different versions of Node.js. We can just add a parameter for Node.js version like this and use this in different recipes to install different Node.js versions using a single YAML file. And we can refer to the parameter using double curly braces notation like this. Now that we have both our custom component YAML files defined, let's create CDK resources to deploy these components. So back in our CDK stack file, I'm adding a component for Apache first. Here I'm setting a name and a description for our Apache component. And the platform will be Linux, and supported version is Ubuntu. I'm setting the version as 1.0.0 as this is our first version of the component. And finally, we specify the location of our YAML file. Here I'm using S3 URL for my YAML file. We can directly put all our commands here using a data attribute, but YAML looks more cleaner. And we need to make sure we upload these YAML files to S3 bucket before deploying the CDK stack. So let me add AWS S3 CP command to my deploy script to make sure our component files are copied to S3 before executing CDK deploy. So here I'm copying the files if my environment is demo-shared. Now let me add our Node.js component as well. Now we can combine these two custom components with the AWS managed components to define our recipe. So let me add the code for our image recipe. First, I'm setting the name and version for our image recipe. Next, we have parent image, which we defined in our CDK context. Under additional config, I'm configuring to keep the SSM agent after building the image. So Image Builder installs SSM agent by default to perform all the build activities. So if we set this attribute to true, it will uninstall the SSM agent after the build. Next, we need to define which components make up this image recipe. First, let's add our Apache 2 component. So I'm specifying the ARN of the component we defined earlier using attribute ARN method. Similarly, we can add our Node.js component, and optionally we can pass in the Node.js version as the parameter. And the name of this parameter should match the parameter name we defined in our component YAML file. Next, we can add the ARNs of AWS managed components, and we can fetch the ARNs from the Image Builder console. And as you can imagine, we can create different recipes for different types of servers by combining these components we need for that type of server. So let's deploy this using our deploy script. So the deployment is now complete. If we check our Image Builder console, we should have our two custom components for Node.js and Apache, and we should have our Image Builder recipe as well. Next, we need to create the infrastructure config. And for infrastructure config, we need to import our existing VPC and create a security group, as we need to provide a subnet and a security group in our infrastructure config. So I'm just pasting the code for importing the VPC and creating a security group. Let me fix the imports. So here I'm importing my existing VPC using from lookup method and creating a security group within that VPC. Now we can define our infrastructure config. As always, I'm setting the name and description. I'm also setting the instance profile name, which we created earlier. And for subnet ID, I'm choosing one of my public subnets and setting the security group ID, which we just created. Next resource we need to create is the distribution config. Let me fix the imports. And again, I'm setting the name and description. And under distributions, I configured my dev and prod account IDs. And once this image is built, it will be copied to these accounts in a specific region, which is Sydney in my case. And you can see that I'm using parameters in the name, and I'm using build version and build date. These values are provided by Image Builder during runtime. Now we can combine all these resources and create our image pipeline. Here we are specifying name and description. Next we specify the ARNs for image recipe, infrastructure config and distribution config. And then we define a schedule using cron expression. So I've set it to run this pipeline on 1st of each month, and you can modify this expression as per your requirements. We also have a pipeline execution start condition, which is set to expression match only, which basically means that the pipeline will be triggered just based on the cron expression. It won't take into consideration whether the recipe is changed or not. And we can set it to expression match and dependency updates available if you want to trigger the pipeline when the cron expression matches and any dependency updates are available. So now let's quickly deploy this. So the stack is now deployed, and on the console we should be able to see our image builder pipeline. And one final resource we need to create is the cross account role, and this is optional and it is required only if you are distributing the AMI to other AWS accounts. The role should be called EC2 Image Builder Distribution Cross Account Role, and a managed policy needs to be attached, which is EC2 Image Builder Cross Account Distribution Access. The assuming principal for this role should be the account ID of the source account, which is shared in our case. So let me first deploy this into my demo dev account. So the deployment is done in the dev account. Now let me do the same in my demo prod account. So the cross account role is now deployed to my dev and prod AWS accounts. So our pipeline is now ready to be tested. So from the image builder console, you can select the image pipeline, and from the actions drop down, we can select run pipeline. You can see a message saying the pipeline execution is initiated successfully. And if we click on the pipeline, we can see the status as pending. After a few seconds, we should see the status of the pipeline has changed to building, which indicates that it is spinning up a temporary EC2 instance in our specified subnet. So if we go to EC2 console and click on instances, we should be able to see a new instance being launched. And this instance is launched from the AMI we specified in our image recipe. If we wait for a couple of minutes and go to CloudWatch logs, we should be able to see a log group created for our image recipe. Within that log group, we can see a stream for the version of our recipe. And all build logs can be seen here. And it can be useful to troubleshoot any issues with our components. Another place to check the status is SSM. As I mentioned earlier, Image Builder uses SSM automation documents to build our AMIs. So if we navigate to SSM console and click on automation, we should see an execution in progress. If we click on the execution ID, we can see all the steps in this particular execution. As you can see, it has a lot of steps, and we can see the status of each step from the console. It might take a while for all these steps to complete. I'll speed up the video until all the steps are complete. After almost 12 minutes, the overall status of this execution is success. If we go back to executions, another execution might have started. And this is for the test phase where it launches another EC2 instance based on the AMI that is created and executes all the commands from the test phases. And if we go back to our EC2 instances, we should be able to see another instance called test instance. And once the execution is complete, both the instances will be terminated. And our build instance is already terminated because the build phase is complete and the test phase is in progress. We can see both our SSM automation executions are successful. The test phase took around 6 minutes for me. And these timings are entirely dependent on your image recipes and components. If we navigate to AMI's section, we can see our new image created with the name Image Builder suffixed with the version and the timestamp as we defined in our distribution config. If we go to one of our target accounts and go to EC2 and then AMIs, we should be able to see the AMI copied to our prod account. So that's the process of creating image pipelines to build golden AMIs and distribute across AWS accounts. So that's all for this video, guys. Thanks for watching. I hope you found this video informative and helpful. Remember to like and subscribe for more AWS related content and updates. Also check out my other videos on this channel for even more in-depth AWS cloud content. Thanks again and see you in the next one.